Welcome to lecture 9.1. This week we're going to jump into the polar coordinates and going back and forth between polar, rectangular, and a little bit in exponential. And taking a look at what those look like with our equations, what they look like on the graph. Our objectives in this section are to plot points using polar coordinates, convert from polar to rectangular, convert from rectangular to polar, and transform equations between polar and rectangular. So we're going to be going back and forth in polar form and what we already know is called rectangular form. So for our first example, we'll go through the point -3 and 2 pi over 3, and we want to plot this point and find other polar coordinates in the form of r theta for the point to meet these conditions. So we're going to do 3 different conditions and find out what the coordinate would be in order for it to meet the specific conditions. So for the first condition, we'll just start with the first one. Our radius has to be positive, and our theta needs to be between negative 2 pi and 0. So we're working in the negative zone. So what we're going to do is take a look at what this graph would look like. So first, I'm just going to graph the original. And where does -3 and 2 pi over 3 fall? So in order to graph this, I'm going to start just with our starting side, and at 2 pi over 3, that would be about right here. Okay. And this is opening this way. That's 2 pi over 3. But we want a negative r, so what we're going to do is we're going to look at this side of it. And we're going to go down -3. So that's our point that we're looking at. This is -3, 2 pi over 3. So that's where we're at. And we need to meet these conditions that, let me go back to this. R is greater than 0, and we're in between -2 pi and 0. So this is the first one. Now, if we notice, our point here is not, first of all, we need a positive r. And second of all, we need to be between -2 pi and 0. Our theta needs to open between -2 pi and 0. So if we start here and we open in the negative direction, right? We're looking at this line here, and we open it up, then we would open it going this way. And in order to get from this point here up to where we want for our conditions, we're going to have to subtract 2 pi from that 2 pi over 3. So that's going to give us, subtract 2 pi. That way our theta is going to fall into that range that we're looking at, -2 pi and 0. We want to be in between there. Right now, we're not in that range. We're above 0. So in order for us to get into that specific theta range, we are going to subtract the 2 pi from our 2 pi over 3. And that gives us a -3 and a -4 pi over 3. But we want our r to be a positive r. So again, once again, we're going to be looking at 1, 2, 3 over here, because that would make positive 3 and negative 4 pi over 3. That's what we want. All right, let's do another. Really understanding where on the graph am I supposed to be. And we don't want to change the point that we're at, we're just changing how many rotations around in this circle do I have to go in order to get there, or which direction do I need to go, positive or do I need to go negative in order to get there. So it's the same point with a different name almost. Okay, so our second one, r is positive again, but this time we're in between 0 and 2 pi. So let's get an idea of what we're looking at here. So we want r to be positive, and we are going to be in between 0 and 2 pi. Well, 2 pi would be going all the way around. So if we're in between 0 and 2 pi, and we're looking at this, we would just go around here. We stay in between 0 and 2 pi. We don't go over 2 pi. This big angle would be a 5 pi over 3. But remember, our r has to be positive, so we're just going to flip to the other side and take a look at that right there. So that would give us a positive 3, and the angle would be 5 pi over 3. Okay, we're doing good so far. All right, our last one, C. Let's see, we want r to be negative, and we want to stay between 2 pi and 4 pi. 4 pi. Okay. So between 2 pi and 4 pi, this means that we need to go over 2 pi. We need to go around the circle a full time and some additional after that. So what I'm going to do is I'm going to add 2 pi to our original 2 pi over 3. That takes us all the way around the circle and then some, and that gets us into that range between 2 pi and 4 pi. So what does that look like? Well, if we start here and we're still looking at this same information, what we're going to do is we're going to be going all the way around, which gets us the 2 pi, and then that additional 2 pi over 3. So really this big giant angle altogether is 8 pi over 3. And we don't have to switch anything, we can just stay right there, and our point stays as negative 3 and 8 pi over 3. Awesome. It really helps for me to visualize what's happening, so I always draw it out, and that helps me see the direction we need to go. It helps me see how to switch between positive theta, negative theta, positive r, negative r. And then if we need to add or subtract, then we can actually see what we need to have happen. Okay, for our second one, we're going to find the rectangular coordinates of each of these points. So let's start with point A. We have -6 and 4 pi over 3. So this is telling us we're at theta, 4 pi over 3, and -6 is our r, because we'll write that down. This is in our theta points. Some other things that we should consider is that x is r cosine theta, y is r sine theta. So first let's find our x value. So if x is r cosine theta, that's going to be -6 cosine of 4 pi over 3. And 4 pi over 3 cosine at 4 pi over 3, that's going to be a -1. Oh no, a -1/2. Sorry. And 6 times a half, -6, and -1/2, that gives us a +3. We'll do the same thing for our y value. So r is -6 sine theta 4 pi over 3. So we have -6, and sine at 4 pi over 3 is -√3 over 2. And if we reduce this, it becomes √3 over √3 times 3. So our xy coordinate, which is rectangular, is going to be 3 and 3√3. Lots of 3's on that one, but that's just the way it came out. Okay, that one was in radians. So now let's look at one that's in degrees. This one is -3 and -346 degrees. So this time we're still working with r and theta, and we're still gonna find x is r cosine theta, y is r sine theta. But this time we need to make sure that if we're doing it in a calculator that we're working in degree mode. So go ahead and change to degree mode before you begin typing these things into your calculator. R is -3, cosine theta is -346 degrees. Cosine at -346 degrees multiplied by -3 will give us about -2.91. Let's do the same for the y value. We have -3 sine -346 degrees. That is going to give us about, so we take the sine at -346 degrees and multiply it by -3. That's about -0.726 if we round it off. So our xy coordinate, turning it rectangular, is going to be -2.91 and -0.726. Okay, now let's find the polar coordinates for these points. So we're given rectangular coordinates, we want to turn them into polar coordinates. For our first one, we have -7 and 3. So just to get an idea of where this point is, we'll plot it first. So just graph -7, +3, somewhere around here. And a line would look something like that. So we can see already that we're in quadrant 2. And that's going to come into, that's going to be important for us because when we're dealing with finding our theta, we need to make sure that we're landing in quadrant 2. So the first thing, let's start by finding the distance from the origin to that point. How long is our r, basically? So remember, r is x squared plus y squared, and we take the square root. This is going to be 49 plus 9, which gives us root 58. And then we also need theta, right? Because our polar coordinates are written as r and theta. So to find theta, what I'm going to start with is my tangent of theta is y over x. And what this means is if I'm looking for theta, that's going to be tangent inverse of y over x. Now, tangent inverse is going to have us between negative pi over 2 and pi over 2. But that's in quadrant 1. We want to be in quadrant 2. So we really need to be between pi over 2 and pi. That's where we need to be, quadrant 2. So when we take our tangent of y over x, what we get is tangent inverse, and plug in y, plug in x, negative 3 over 7. This places us at about, remember you're looking to be in quadrant 2. This places at negative 0.405. This is in quadrant 4. Okay, so remember we talked about finding that quadrant at the beginning, and this is why. We found theta, but our theta is in the wrong quadrant. And remember what we did before in those examples to get into the other quadrant, we just added pi. So we're going to add pi, and that will get us 2.74, which is in quadrant 2. And that's what we wanted. Since this answer, since 2.74 is a rounded off answer, what I'm going to do is I'm going to round off our r as well. Radical 58 is about 7.62. That way when we write our theta, we can write them and they're both in the same format. So we have 7.62 and 2.74. That's our polar coordinates. Just do it down here. B. Okay, so in B, we have the point negative 3.4 and negative 2.6. So where are we? Negative 3.4 and negative 2.6 is about here. So we're in quadrant 3. And so let's find r first. This is going to be 3.4 squared, 2.6 squared, square root of these, which is about 4.28. then let's find theta. Same as above. We're looking at tangent inverse y over x, which is the tangent inverse of negative 2.6 over negative 3.4. And that gives us about 0.653. Now this is in quadrant 1. We want quadrant 3, so we're going to add pi. Add pi, and we get about 3.79. So our polar coordinate of r theta is 4.28 and 3.79. All right. Example number 4. We want to write our equation x squared equals 2y using polar coordinates. So again, we're going to be referencing x equals r cosine theta, y equals r sine theta. And so if we just take our equation, x squared equals 2y, and plug in what we know about x and what we know about y, x is r cosine theta. So everywhere I see an x, I'm going to put an r cosine theta. So I have r cosine theta, but it was x squared, so that's going to be squared, equals 2 times y, and y is r sine theta. And now, in order to write this as an equation that is more commonly seen, what I'm going to do is I'm going to move everything to one side. I'm going to just subtract this over to the other side. R sine theta. And whatever I do to one side, I have to do the other. So those cancel out, and what we have is r squared cosine squared minus 2r sine, and now it equals 0. And that is where we'll stop. That is our equation using polar coordinates. We have our r, we have our theta, we don't have any more x's and y's, so we're good. And lastly, we want to write this equation, r equals 8 cosine theta, using rectangular coordinates. So we're going backwards and starting with polar and turning it into rectangular. The first thing that I'm going to do is multiply everything by r, because what I know about r is r squared equals x squared plus y squared. So I see an r, and if I could get r squared, then I can change it into x's and y's. So I'm starting with r equals 8 cosine theta, and I'm going to multiply everybody by an r. So on one side I have r squared, and then I have 8r cosine theta. Now, r squared is x squared plus y squared. So I'm going to rewrite that, x squared plus y squared. And then another thing that we should be able to recall is that x is r cosine theta. And we have that on the other side. We have 8, and we have r cosine theta. Well, r cosine theta is x. So now let's write this in standard form. So we have x squared, y squared, and we have 8x. I'm going to move the 8x to the other side. So now we're going to have x squared minus 8x plus y squared equals 0. Now from here, we can complete the square. If you don't remember that, pause and go do a quick review. But basically, we're going to take this part right here and we're going to complete the square. So 8 divided by 2 is 4, and 4 squared is 16. So I'm going to add 16 to both sides. X squared minus 8x plus 16 equals 16. And this is factorable. X squared minus 8x plus 16 is x minus 4 squared. And this is the standard form of a circle. So now we have the standard equation of a circle. We have a center of the circle at 4, 0, and a radius of 4. So we're good. We changed it into rectangular coordinates, and we even got it into standard form, and we can recognize it's a circle. That's it for this section. Make sure that you have a really good understanding of what is happening with our polar coordinates versus rectangular coordinates, because this is going to be really important for this section.